So my name is Mark Sanders, and I am in what's called the Global Technology Office inside of Dell EMC, and I'm going to be talking about why architecture matters when you're talking about data protection. And really trying to level set, make sure that everyone in the room and everyone out watching really understands the value that Dell EMC offers in a data protection landscape. And our point of view is that part of that value really comes from the design and the architecture of that solution. So let's take a quick trip down current standings memory lane, right? So, no one's hitting the delete button. I don't know, show of hands. Anyone know of any customers hitting the delete button, right? So that's not happening anytime soon. So data's getting bigger. And backup windows, people's ability to recover, right? Most folks in the normal data protection world want to be able to back up in less than 12 hours so they can hit an RPO of 24, right? They want to be able to recover at least yesterday's data. And so if data's getting bigger and backup windows are staying the same, something's got to give, right? Now you add on top of that mission critical applications. It's gone crazy, right? Back in 07, when I was out in the field as a sales rep back in the day, I saw 1 terabyte database. Just never, right? The average database size was under 100 gigs. Okay, we do a ton of assessments at Dell EMC. Last year we did over 25,000 backup assessments on our software and competing software, and I can tell you the density of database data is shifted, right? So we used to see a density of about 100 gigs. Now we're seeing a density at 1 to 3 terabytes, and we're seeing a ton of outliers in that 15 plus terabyte range. And let's just be honest, folks, it's not the backup that's the problem when it's 15 terabytes plus, it's the recovery, okay? So we got challenges there. Now, virtualization of large mission-critical applications also has its own set of unique challenges. There's some traditional ways that you approach this, but we have come up with some new data movers, some new ways of handling this, and we're going to talk to you about that today. And then the rise of cloud, right? A ton of customers have shifted workloads to the cloud. They're looking for snapshot management in the cloud. They're looking for application consistent backup in the cloud. And we're going to talk about how architecture matters even more so when it's in a cloud paradigm versus when it's on-prem, okay? And then lastly, I don't see anybody out there in the world not still trying to optimize costs, right? And that's kind of the balloon. And then when you, yes, everybody wants to be cost effective. And that's really the problem. As things get bigger and you push on that balloon, it's really hard to uniformly push on that balloon unless you've got some really good architectures that scale well and are optimized for cost. Okay? All right, so now that we've discussed kind of what's out there in backup land, let's talk about some just level set on a couple of things. My point of view from a high level, there are 4 key ingredients in solving backup. You've got policy engine, you've got data movers, you've got networking, and some sort of protection storage, okay? On top of that, our point of view is that it's a math problem, okay? And, we really pride ourselves at Dell EMC of having some really good solution design tools, having a very well-trained sales force and pre-sales force, using really good assessment technology, and really solving that math problem with our customers. Sometimes when we're out there competing with the competition, this is where I just kind of chuckle because it seems like some of our competitors don't think there's a math equation here. And so let's just kind of go down a rudimentary equation. We got 1,000 servers. Let's just say the average backup window is 3.5 hours. I do some math for a 10-hour backup window. I need 350 simultaneous write streams to hit that. That's assuming that each backup job is only using 1 stream. Okay? Now, the reality is most database backup jobs are going to use a couple of streams if you're using an agent, right? So, and depending on the technology you're using, it may use two streams to do a VMDK backup, a CBT backup, just it depends. So there's a stream equation here, and that's really kind of a fundamental underpinning of our architecture is the performance and number of streams we provide and the unit size that we provide it at. And then the last 2 things, show of hands, everyone understands global source side dedupe. Do I need to explain that? Okay. And then data domain, 2 key kind of fundamental things around data domain, and its architecture, obviously it's a deduplication file system in an appliance build. We also have a software version of it. And it has inline global dedupe and has a key feature here called data and vulnerability architecture. This is kind of a key kind of secret sauce and why EMC at the time spent $2 billion for data domain. Now Dell EMC owns data domain. And that fundamental architecture is why we call it protection storage. It's designed for protection. It adds an extra check bit when it's writing that data down to disk, stores it in memory so that if you have a loss during the write, it can recover itself, and then it validates itself on a weekly basis. It's actually running a mini DR test across the entire file system on a weekly basis. There's really no other solution that I'm aware of that's doing that level of validation on your backup data, period. There's other people claiming erasure coding's great. There's other people who do spot checks. But the reality is they didn't design their systems from the ground up to validate their data. They didn't think it was important. They used RAID coding, or it was an afterthought after the fact. And so they have this kind of post injection of dedupe into their system, and then they really didn't have the ability to design that validation in. So that's kind of a key point. Okay?
Well, to be excessively snarky, the VMAX guys yesterday were telling us how they scrub data daily, and you only do it monthly.
Weekly.
Weekly.
But you can run a cleaning more often, but for us, it's now a background process that runs on an ongoing basis. The other key thing, and I talked about how data is getting bigger, right? And this is kind of the historical data protection design here. You've got applications, you put an agent on them, you write data to a media server, and that media server writes to disk. We call this an A to B, B to C. Now, what's happened is over time, different vendors have taken this thing and encapsulated it, and so you have a B to C issue they've somewhat solved, right? The issues of getting data from here to here, they've somewhat solved it. But the problem is, and this is really where that global source-side dedupe technology that we own is, that still leaves you with an A to B issue. And as data gets bigger, although you've solved your B to C issues, the only way you can keep up with the Joneses is to multiply this bad boy here, this building block, and keep adding them and keep adding them and keep adding them, and adding a lot more networking, because you're not efficiently transferring data from A to B. You're really not able to keep up. And as things get bigger, it gets to be more of a problem, and it gets pronounced. I'm not saying you can't solve it with just this kind of building block. It just becomes harder at scale.
I think you're referring to data in general that's dedupable in use cases such as medical, healthcare, imaging, videos that doesn't get dedupe capabilities. The dynamics you're talking about don't apply, correct?
Yeah, and so great point. And so if the data is music, videos, images, things like that, our recommendation would be that should lie on top of an object platform from the get-go, and you should use geo-replication and erasure coding to protect that sort of an application.
So in that case, though, you're saying that it's okay not to have the extra rigor of having the extra check and all that stuff? Or?
When the documents don't change on a regular basis,
okay, it's
a different story.
Okay.
From our point of view. So just fundamentally just level setting on that. Where did I drop the clicker? All right, so with that, let's dive into our architecture from a VMware construct, because I think that's a good place to start and really help you understand kind of how we got here and why we feel our architecture offers a lot of value. So this is the picture. I'm going to build this out, but I'm going to go to the whiteboard here and kind of just talk through this. So I talked about how there's a policy, a data mover, and some protection storage. And our design, using global source-side dedupe, allows us to write data very efficiently across the network. And if you kind of take a step down memory lane, let's talk about a couple of key concepts. So for a long time, in data protection land, the predominant thought was from the competition is that the way I'm going to speed up data transfer from A to B was I'm going to use a SAN fabric. So I'm going to use a bigger pipe, so I just can shove data through it. And it really doesn't matter how efficient A to B is. To me, I'm just going to use a bigger freeway. Give me an Autobahn, okay? And so if you look at the competition from a data protection standpoint for VMware, they went down the route of what I call SAN transport, right? Which is a protocol used in VMware to write across SAN fabric. And they really spent a ton of time in engineering certifying every array vendor out there. So I call this at the array layer using SAN transport. Well, guess what, folks? Dell EMC never really spent a lot of time here. So good, bad, or indifferent, if that kept going, we would have had to pivot and do something about that. We were starting to, but the rise of the software-defined data center came along, and the rise of things like vVols and vSAN came along, and guess what? This protocol currently is not supported under that software-defined protocol. And so this is a pivot point, right? So we had spent the last 5 years really engineering some of the best and most efficient data movers over the network. Our proxy automation, our ability to leverage a small resource proxy and move a lot of streams, do global source side dedupe, the ability to automatically deploy proxies based on querying vCenter, how many VMs do you have, what's your average backup time, what's the backup window you want to hit, do you want me to deploy more proxies, do I put them in the right spots to optimize SCSI hot add? We have been doing this for a very long time. So the rise of this software-defined data center, let's just be clear, we got somewhat lucky. We're a little bit ahead in the automation and the networking side. And so this has really put us in a really kind of a sweet spot around VMware and scale. And here's where we're at. When everyone talks about automation, from my point of view, they're really just talking about policy, right? So, you know, hey, I create a VM, I stick it on an ESX server, it gets a policy. Hey, I create a VM, it's in a folder, it gets a policy. Hey, I create a VM, it's tagged this way, it's named this way, I get a policy. That's what they call automation. Now, yes, that is automation, but what about all the other stuff, right? What about how do you automate deploying more data movers when you add another 100 VMs? How do you do that? How do you deploy automatically more protection storage and say, this kid rides in this car, this kid rides in that car? And that becomes kind of the story that I'm telling you, is that our architecture really allows us to automate the entire stack. And I can go down the line and say, yeah, everybody does this, but that's where automation ends. And really where we start to shine and they start to have problems is around automating the rest of the stack. And let's be honest, I mean, backup is one of those necessary things that IT operations needs to remove risk. But who wants to be in the business of deploying more media servers, more bricks, or more nodes, or more whatever, every time they kind of don't hit their backup window? And that's really kind of the power of our agility and our architecture. I'll pause there and see if there's any questions.
On your screen there, you have data domain VE.
Yes.
You're going to go into more detail as to what those things are, I'm hoping?
Sure. So from a protection storage standpoint, we offer choice, right? And our strategy is really to give that flexibility. And the bigger you are, the more likely you'll have multiple deployment models. So we have our classic do-it-yourself, purpose-built backup appliance. You deploy the software on top of it, and you integrate together. We have a pure software version of that, where you have a data domain virtual edition. You have virtual editions of all of our backup software, and you can deploy those two together independently. And then the third one is an integrated appliance, where we've pre-packaged, pre-installed. We have all the compute in there, and it comes preloaded, and it's more of a simple experience to have that integrated. So you basically have a purpose-built backup appliance, build your own. You have a pure software-defined version of our kit, and then we have an all-in-one that's software, hardware, all pre-installed, pre-configured.
So, I mean, my knowledge of the platform is rudimentary, so forgive me if I
sure, no worries.
Up, right? So the data domain technology that you guys bought for $2 billion back then was target technology. The data movers, that layer, the data movers, that's not data domain technology, correct? Or is it not? What is it?
So it's a little of both, right? And it's a good segue because we are going to talk about the different data movers that we have in our portfolio and how they work kind of at a high level, and then later we're going to talk about it. But you've hit on a key thing here. So global source side dedupe is enabled from us by a couple of technologies. The first one is something called DD Boost. DD Boost, in layman's terms, the way I explain it, is the replication client that data domain uses to replicate efficiently from one device to another. It only sends the net new unique data that doesn't exist on the other side. What we did is we stripped that technology down and we embedded it in our software agents. We embedded it in our plugins for things like SQL, Oracle, DB2, SAP, HANA, et cetera. And it's the underpin of this efficient data transfer across our network. We can also move it over fiber, but its network capability is really the fundamental value that it offers because it gets that global dedupe. It only sends unique data. And what we've seen is about a 50% reduction in backup window compared to not using it. But the other real value is about a 95% reduction in network traffic. Okay?
Okay, just let me point out.
Yep.
We're not laymen. We're not really interested in layman views.
Fair enough. I'll give you the more detailed version.
We are at least journeymen.
Good.
What's the maximum distance between the virtual machines and the backend protection storage?
So that's a really good question. Glad you asked. So, Boost for enterprise apps, or the Boost protocol, is really designed for a data center workflow. But we have stretched its limits. It will work over distance. It's got two key kind of requirements for it to work. It needs at least a 10 megabit bandwidth connection and less than 30 milliseconds of latency. Now that's our spec. Now in the wild, people are doing it way past that, but that's what we stand for with and say we support this. Under RPQ, we've approved other scenarios, but as a general rule, those are the kind of the scenarios. Now, it's true we have in our portfolio, our Avamar technology has true agent-based WAN backup, and that really doesn't have any limits. Really, if the data can transfer, it can transfer. It uses more Pcache, Fcache settings. It's a term for caching at the source, the segments that's already transferred, so it's way more efficient before it transfers, where Boost will actually query data domain and say, do you have it? Do you have this? Do you have this? Do you have this? Before it sends it. So there's a lot more chatter with Boost, so it's more of a data center play by design.
Yeah.
What's the entry point for data domain?
Cost-wise?
Cost, size of customer, size of data?
Yeah, so data domain sizes scale from a 4 terabyte appliance, currently today like a DD 2200. I think ASP with 12 months of support is like 10 grand out the door. All the way up to DD 9800, which as you can see here has 1,885 simultaneous read-write streams that it can handle in a single rack. And you don't need a whole rack to get that. You just need the head unit and a couple of trays of drives. Back to my point before, in an enterprise where I've got a lot of simultaneous backup streams required to hit my backup window, I can really, really scale with a very little amount of kit, get to a large number of simultaneous write streams to really crush the backup window as people grow. Okay, great questions. All right, so I talked earlier about, this is the world we live in today, and from a VMware standpoint, if I had a mission critical app that was causing a VM stun issue and causing the database to crash, causing the VM to crash, what I would traditionally do is I would install an agent on that, and I'd do a persistent VM drive letter on that database drive so that when I did a snapshot, I wouldn't mess with the database, and then I'd come by on another cycle and go grab the database. Or I'd grab the image once a week and grab the database daily, something like that. That's how we've done it forever, and that's pretty much how everyone does it now. And there's a couple of reasons why VM stun happens. The primary one is around higher change rate, so somewhere around 15% daily change rate. Change block tracking becomes irrelevant. High I/O, image backup becomes kind of irrelevant. It causes these issues. And there's another third one I've kind of seen kind of sporadically, like every third full moon. If you have a front-end server, like maybe an SAP front-end server that doesn't have like the high change rate, maybe not high I/O, but has a lot of tiny little transactions going through it, just can't keep up every so often, it crashes. And so this has kind of been the somewhat of a delay why in enterprises people still run big databases not virtualized. It's because of these performance concerns, and it's not necessarily can VMware handle it, because it sure can. It's can you have a backup application back it up properly and recover it fast enough to keep up with it.
Well, more frequently, it's that there's just no advantage to virtualizing it. If you have 400 two-socket servers running vSphere and 2 4-socket servers running Oracle or SQL Server, you could put VMware on those 2 4-socket servers, but those VMs can't run anywhere but those 2 servers anyway. So you just spent money for no benefit.
It really just depends on the design, and some of the mobility and agility of VMware can be a detriment depending on your business and how you're going about it. But if you were to want to go virtualize a 5, 10, 15, 20 terabyte database, and think about that paradigm in the cloud, it just becomes even worse. What are you going to do? Right? Now, we talked about this before. It's not the backup per se that's the issue, it's the recovery. So when you have a 10 terabyte database, most of the time you're going to recover with 4, maybe 8 streams. And depending on your network and how much direct access you have, it is going to be what it is. And if that database gets even larger, it could take days to recover if you truly needed to recover. And this is why being able to do a VMDK snapshot of a large database and then being able to virtually mount it on something else instantly is a real benefit. But if you can't do that VM backup anyway, because of these stun issues and it keeps crashing the database, it becomes kind of a moot point.
Well, that's what vVols are for.
Well, we have definitely made some improvements there around the snapshots, and vVols is definitely going to help. But still in the recovery, it's going to be a little bit tricky. So we have designed something that goes beyond VADP. And Paul Megan, who's up after my section, is going to dive into this and go into the bits and bytes and really hopefully there'll be a lot of questions here. And we feel that this is kind of the different way of solving this problem, right? If I look at the marketplace and I look at the competition, most of the competition that's come on board in the last 3 to 5 years has really gone at this from a crash-consistent image backup standpoint. Whereas we've taken the approach that we had a really awesome crash-consistent product, and now we're coming at it from the top down and trying to solve the harder to solve problems, trying to solve the mission-critical application problem, and then we'll come bottom up and eventually optimize the crash consistent as well to tie it together. But this is really unique technology for us, and we're calling this Hypervisor Direct. So I wanted to take a minute to make sure that we kind of level set on the different data mover questions that you asked about kind of what do we have. So if you think about it, the first one we have is something we call Client Direct. And Client Direct allows us to write straight from the app, straight to a data domain. Sorry, the drawing's bad. And then send metadata to the backup server. Metadata is used to catalog, to do clone copies, to allow you to make a tape copy or make a clone or whatever. And this is really efficient in the data center because we get rid of that media server on the right. And we're only sending deduplicated data straight to protection storage, right? So this has been the design factor that we've had for a while.
What software is that agent? Is that data domain software or what is that?
This is either Networker or Avamar today.
All right, so that's Networker or Avamar, thank you.
Networker or Avamar. The next layer that we added is we took that Boost technology and we embedded it into application API plugins that sit on application hosts like SQL, Oracle, DB2, etc. So you don't need a backup app. All you do is you use the native tool set with inside of SQL or Oracle RMAN, and you drive your backups from there, and you use that efficient Boost protocol, and you send it client direct, app direct straight to protection storage, and you use the native tools to drive that. And DBAs really like this because they were using native tools before. This makes it very, very efficient. Sorry.
Yeah, but we're storage guys, and DBAs are our natural enemies.
I thought that was the network guys.
Well, this
Everybody hates the network guys. Aren't you trading host CPU cycles for network bandwidth? And aren't you therefore assuming that my main Oracle database server on which Larry wants many, many thousands of dollars per core as a license fee has CPU cycles to spare for your backup process?
Good question and a great softball into the next data mover that we have. Appreciate you bringing that up. The reality is you're right. To get optimized backup of a large database, I am trading CPU, but the other side of that coin is that the amount of time which I use that more CPU is shortened. So if I look at a traditional backup where I rise this much and I use it for 10 hours, right, I'm going to rise maybe 15, 20% higher than that, but I'm going to use it for half the time. So in the end, you add up all the dollars and cents. The problem is if you don't have enough time and cycles within that. Like if you can't spare that extra, you can't do this. So it is what it is. It's definitely revolutionized a ton of database backup, and from a storage perspective, it's gotten the database admins off of the storage arrays where they're doing all their squirrel copies, and it gives them a place where they can do their backups and control their own backups that don't hit your storage. So,
but you have put some code on their database servers, which they're never very happy about.
So the API plugins, depending on the application, there is a little bit of work to do, but it just depends on the application, and each vendor is kind of different. And installing that API is not a big deal in some cases. In other cases, yeah, it does require some.
It's got to be validated.
Not a big deal from our point of view, and not a big deal from the DBA's point of view. Are completely different things.
Yeah.
So there is
DBAs are hard.
Agents are inherently evil. The question,
they don't like them.
And if you say my agent isn't very evil, the DBA still goes, "Ooh, evil!
Yeah.
Back, get me some holy water."
So fair enough, and that's really why we've kind of advanced this technology. So we've taken that code, and so we had these plugins to give more control, more performance. In the case of Oracle, because of this code, the Oracle application is aware of copy 1 and copy 2. So it's like intrinsically aware because it knows it's writing to disk. Now, what we've done on top of that is we have a variation of this protocol called BoostFS, and that uses CIFS or NFS. So we've taken that layer and we've put it at a CIFS or an NFS layer. So you're basically installing a CIFS or an NFS client, not anything on the actual application itself, and you get that advancement in data transfer. The other unique value of that is that actually helps some of my competition and their backup software write more efficiently over the network. So we've seen some customers get some advantage of that. And it also has the other intended benefit of really helping us protect at a much more efficient way new databases that don't have fully developed application control for backup, things like Mongo, Cassandra, so on and so forth, that live in the cloud where network is a premium, and having any data mover that really efficiently transfers over the network is a real cost savings. Okay?
Quick question. I'm seeing direct to the backup structure right now.
Yep.
Are you seeing clients still building out separate dedicated backup networks to isolate for security reasons so that we're not pushing this across the regular
If you're in the
network?
federal government, we're still seeing secure and non-secure networks. Dedicated backup networks, I'm not seeing as much.
Okay.
But if you're going to stay down the route of using something that just does B2C encapsulation and doesn't answer the A to B issues, that's your future, is 40 gig networks and things like that.
Yeah. Okay.
Yep. So the next one is we did a better together story with our own primary storage. So VMAX 3, Extreme IO, we created integration between data domain, used that boost protocol to create a fiber channel LUN that virtually mounts on a data domain. Paul Megan will go into more detail around this technology, but this is really a game changer because it not only solved the backup, because I only move change blocks on a 100 terabyte Oracle database, so I'm basically managing snapshots on a VMAX and then actually writing the changes across the wire to data domain and smashing a new full, and every backup's a full and every recovery's from a full. It's actually pretty slick technology. And the real value prop here is that if you have bare metal attached LUN-based apps that are huge, this is going to crush that backup. And most importantly, really, really crush the recovery. We've seen huge benefits from this on even medical information applications like Epic, where you have these massively scalable cache databases that have a short window for recovery and backup. This technology has been game-changing for that environment.
Okay.
Yeah,
In a while.
and now what we think is kind of revolutionary, and I kind of hinted at before, that I call that hypervisor direct, is doing the same thing again, but doing it at the hypervisor layer. So now you've taken this application and you've encapsulated it inside of a hypervisor. And we talked about VMDKs and VADP backups having that stun issue. This is basically our way of circumventing that quagmire and developing a new way to handle mission critical applications. And Paul's going to talk about that later in more detail. Okay? So those are our data movers that allow us to efficiently move data to our protection storage. Because we're very efficient across the network, I don't need a lot of networking. And I have a massively scalable protection storage unit that has thousands of streams. So depending on your size, whether you need to start small and you need to scale, it's a very efficient architecture to move data from A to B and massively scalable. Now, that's great, Mark. That's awesome, Dell EMC, but you guys have a moniker of being too expensive and all that great
well
technology.
deserved.
All that great technology you have, all that scale, that comes at a huge premium, right? And so it really doesn't matter to me as a customer if all that great stuff just costs too much, right? And there's definitely a groundswell of good enough. Like I just want good enough. It needs to work. I need to be able to hit my backup windows, but it's got to be cost effective. I don't know if that's something that you all are feeling, but it's definitely out here. So we have a process inside of Dell EMC where after we've actually done the sale, we come back and we do another assessment. And remember I talked about how many assessments we do where we pull this backup data for the last 30 days and we can see all the objective data of what's really happening. So we have this process we call validate the value, where we go in 6 months after it's in production, compare the new assessment to the pre-assessment, and then really validate the actual cost to serve. How much
So what do you do in an assessment?
So we pull the catalog off of the backup application and we pull all the backup reports for the last 30 days, job, how much data it's sending, how fast it was sent, how long the backup window took, how many files it has, that sort of stuff. And then happy to share with you one of these assessments afterwards. And then we have this really short summary slide that I'm going to show you. This is the V2V, kind of summary slide. And this gives the high-level stats on how things are working in the environment. This is how much data you're storing. This is how little of a footprint it needs. This is your dedupe rate. This is your capacities. Have 98% of your jobs finish in under an hour, right? 99% success, 97% success rate. And then what we do is we take the actual dollars that they spent on the entire solution, including support, and we divide that into how much data we're storing, and we get their logical cost to protect.
What kind of tool are you using for that?
I'm sorry?
We got a question. What kind of tool are you using to do the assessment?
So we have an assessment tool. We have a relationship with a company called MyTrends that hosted our tool where we pull the assessed data in and we process it and spit it out. We now have our own tool with inside Dell called Live Optics that uses a regular command to dump the database, and then we parse it, So it's the actual data from the customer, and we just parse it and present it in a PowerPoint format.
Okay. I'm sorry to the coffee just hit, so
No worries.
2 slides ago. DD Boost, going back to DD Boost for a second.
Okay.
Understand how that works, where that's talking over the network, getting the metadata over the network. You didn't talk about restore. Does DD Boost do anything for restore?
Yes. So we've turned on compression on recovery for restore. So we are able to both get dedupe on a backup and then compression on a recovery.
Compression on restore.
Yep.
Okay, so if it's an uncompressible thing, well, actually that's different anyway because you wouldn't dedupe, but in a regular
It just
store format.
depends, right? If there is some uncompressible data, you're just not going to get any real value out of it. It's going to be the network speed to recover. So.
Okay.
Yeah, but you can't dedupe or restore.
Well, no. Well, if you already had a database.
Well, as
if
a
you-
partial-
Well, Avamar, I think can. I think on the Avamar side you can.
Well, you can do a delta
You have a
restore.
cache, right? Yeah. But no, I was just.
If I have 100 gigs to restore
You're not gonna have it all
and
there.
I can compress it 2 to 1, I'm going to only send 50 and then unpack it.
It's
when
still
I
better than 100. I agree.
Yeah,
I'm
it's faster on a recovery.
But I never really thought about that from the DD Boost perspective.
Yeah, and that's really the limits of stream-based backup is how many streams I can shove this way and how many streams I can shove that way. You got a 2 gigabit backplane on a server. There's only so much data that's going to come off that thing. Right? These are the laws of physics that we live with.
Yep, that's fine.
This is why for this kind of applications, snapshots and replicated snapshots are the first line of
Right.
defense.
Totally agree. I'm a 100%
You know,
supporter in what I
if I'm-
call a layered defense.
If I'm actually restoring a 2 terabyte Oracle database, all hell done broke loose long before it gets to the point where I'm running the data mover in reverse.
Best to not move data at all to restore it, right?
Yeah.
Well, and that's really where those advanced data movers that we have, Storage Direct and Hypervisor Direct, are really going to step in. Now, I'm not suggesting by any means you shouldn't do snapshots or shouldn't have CDP technology.
get it off
You
box.
definitely want, think about it as a military defense. You got a layer, multiple layers, and then the outer layer is that point-in-time app consistent backup for compliance and recovery. If everything all else fails and you can't do it, you got to do it.
You started this slide by talking about you're known for being at a certain cost point.
Yep.
This seems to be that you're still at that cost point, but you're proving you were worth your money rather than addressing the initial cost point.
So the argument that I'm going to make is that what we've done is we've really done it's more of a rumor than an actual truth that we're expensive. And when you actually go do the math, due to how much data we're storing and what you pay, and you do the math, our cost per gig per month is substantially lower than competition. And really, when you look at a full TCO from a competitive product, right, I describe some of our competition, they're kind of like boiling a frog, right? If you put a frog in a pot and you turn the heat up slowly, it has no idea that it's being boiled and it just dies. And that's kind of what some of our competitors do. They get you hooked on this low initial ASP, but the building block and the way that they build, they keep growing and growing and growing. They add a bunch more network and they add more of this. And over time, this becomes a very expensive thing. And if they did the math, their cost to serve has gone substantially up.
Well, this is why I was
where it
asking about
started.
the virtual edition most of all, because the data domain from at least the beginning, I think you guys may have changed the model, and I'd love to learn about it, was that you bought an appliance, it would sit there, and then in 3 years, you'd have to refresh that technology. And with the backup technology, you got to, the TCO, your TCO period, the ROI period, it's got to be longer than 3 years. It's really the length of your data retention, or how long you think it's going to stay in that box. So it's like, if I have to rebuy an appliance with software every 3 years, people, not just with data domain, with a lot of other appliance technologies, they're getting sick of that.
Yep,
So they want to have hardware they want to refresh, but they don't want to rebuy the software.
Yeah, so you asked 3 great questions. I'm going to try to answer them in rapid succession. So one, we've done some great things with Dell financing to make that process more palatable. We're using what we call a transformational license agreement, or your classic ELA. We can actually strip the software off of data domain and make it repurposable on another hardware appliance. So you're really only rebuying the hardware. And per our, the software is now about 38% of the cost of the thing. So you're really buying the other one, and as COGS go down, you get that cost savings. And then the third one
so
is,
if I have a DD880 and I need to replace it, then you're going to sell me the servers that are the head of a DD990.
if you
and not-
had the software under an ELA, then you would only need to buy the hardware components to upgrade to a new one.
Okay, so if I
Just
knew
like,
I
just like
want,
a VMAX, you take the software off of it and resell the hardware. Same concept. It's no different.
Go ahead.
yeah, but what you're really saying is if I knew I was going to want to do this when I bought it and I was smart enough to negotiate this in, you'll take care of me.
Well, it's an ELA. That's why you got to do an ELA.
Just depends.
You're not big enough to do an ELA. That's why I go back to the virtual edition, though, right?
Yeah, so we do have a virtual edition. Starts at a 0.5 terabyte. We have a try and buy for that. You can go and play with data domain.
How big does it go?
It goes all the way up to 96 terabytes in a single data domain virtual instance. Okay,
That's
96 terabytes.
usable.
not, and you could write it on any
usable and effective are terms that mean
Get
different
fuzzy.
things for different vendors. So it's
Post-dedupe
post-protection, pre-reduction, or
Is it managing
post-production.
96 terabytes underneath it? Like if I expose 96 terabytes,
It's going to have
yes.
96 terabytes of actual disk on it that
Storage,
you can
fine.
write to and then get dedupe on top of that.
That's,
Okay.
And it's virtual, so it's
But actually, you could have a
it's
petabyte of data in
post-protection.
there, right? You could have dedupe data in there.
You definitely are deploying more than 96 terabytes to get 96 terabytes due to the RAID configuration.
Yeah,
Yeah,
but,
yeah,
yeah.
But that's
But you're
underneath.
exposing a 96 terabyte data store to the.
Yes.
That's actually not bad.
Yeah, there's
for VE.
yeah. I mean, anytime we're talking about anything that does reduction, there's three levels. There's raw.
Right.
There's post-protection, post-RAID,
Yep.
pre-reduction, and then there's post-reduction where we have to assume some rate of reduction.
That was the second one you mentioned.
Fine.
Yeah, that's actually a good thing because now you're mobile across. As I refresh my hardware.
This is an edge to core play. This is a core to cloud play. This is a gap filler. Hey, I need more capacity. I don't have another data domain yet physical here. Now my point of view is that depending on your size and your requirements, you're going to have multiple deployment models, right? The reality is over time. A purpose-built backup appliance has really been cost optimized. If you truly know what your workload is and you can buy for it, as he was describing, plan ahead, you can really cost optimize. But when you need kind of something quick and easy, or you need some more diversity or some flexibility,
Every enterprise client I'm talking to today is getting away. They do not want to get locked in appliances at all.
Yep.
They want software
Software-defined.
and
Yep.
everything's gonna be software defined. And I don't mean the software defined that everybody here scale out. That's not what I mean.
Yeah.
But they want to decouple the value software from the commodity hardware because
we support it.
right, and that's a great thing that you're doing that because
Yeah,
I think
and we
that's
completely agree. I mean, every customer's got different needs. They got different use cases. If I come in there as a hammer and say everything's a nail, it's not going to win, right? And that's really kind of the other key underlining architecture message I'm telling you here is I have a software-defined version, I have a purpose-built backup appliance version, and I have an all-in-one appliance version. If I'm vendor XYZ, all I've got is an all-in-one appliance. If I'm another vendor, all I have is software-defined. But if you really want cost optimization, you want a purpose-built backup appliance to drive out costs, you want guaranteed performance at scale, they can't help you. And so really that's the business we're in, is making sure you have the right tool in your bag to deploy to meet your needs. Now back to the cost thing. The point I'm trying to make, and maybe it's not coming across well, is we took a boatload of these validate the values from actual customers across the globe, America, EMEA, China, and we handed it over to ESG, and they went and validated the data with the customer, dove into the actual costs, looked at their actual deduction rates, and they came back with the economic value of data domain. We have some copies of that white paper here. What you're seeing is the cost to protect on data domain is sub-penny a gig across the board, in some cases extremely low. And so that's really the kind of the underlying theme here is if you've done your math right and we've sized this thing right, it's efficient, it's cost effective at scale. Definitely going to agree that there's some acquisition cost points in the commercial market curve that we don't play in very effectively yet. Okay, and there's room for improvement in the future for sure. But when it comes to enterprise scale and performance, and even tier one mid-market customers and up, the 40 plus terabyte customers and up, we're very, very cost effective. Now, it matters even more so in the cloud based on our architecture. Now, there's a couple of fundamental things in the cloud that a lot of people kind of just dismiss, right? A classic approach for cloud protection is I take my on-prem thing, I virtualize it, and I certify it to run in Azure and Amazon.
Somebody's certified a tape library to run in AWS?
AWS does have a tape service.
Sorry.
But you take your building block, your encapsulated media server and protection storage device, your virtual appliance that does dedupe or whatever, and you virtualize it, and then you somehow make it run on AMI and you make it run on Hyper-V in Azure, okay? Now, initially you're like, yay, great, I'm in the cloud. But then you're like that frog getting boiled again because the cloud economics, right? And so when you look at the cost of running a persistent anything in the cloud, that's where you get burned. And so if you have a building block that's 16 cores and 4 terabytes of flash and 164 gigs of RAM, and you need that for every 100 streams that you back up, you find out that that's a C-Class Mercedes you're never going to get to drive. And if you need that for every 100 servers you're going to protect, this is going to be a very expensive proposition. And that's actually the bill of goods that my competition has been trying to sell all you. And we went and worked with ESG again. And we went and said, okay, here is the cloud-proven requirements for their persistent kit to run in the cloud. Let's not go measure the cost of the software. Let's go measure the cost of the infrastructure required to run the bits. And figure out what is the cost point to run the infrastructure to require the bits. Again, we got another white paper here that I'm happy to give you. And what you see is, because of our architecture, because we have a very efficient architecture in the cloud, where we have a small backup server with very small footprint, we have a small dedupe engine that can write deduplicated data to object, and we use a global source-side dedupe, and we write client directly to that object pool with this very efficient building block. We have truly optimized cost at performance at scale solutions for the cloud that, quite frankly, the rest of the competition is still busy taking their multi-node faceted thing, persistent kit that's just this huge, expensive Mercedes-Benz. And they're telling you need one of these for every 100, 200 backup streams you need, whereas my building block can scale to 1,000 simultaneous backup streams with a very small little footprint.
Are you talking specifically about backing up AWS EC2 machines to
I'm talking about
AWS?
in-cloud data protection, right? I'm running something in Amazon. I'm running a SQL app there, and there's persistent data that I need to do retention on for compliance or whatever, and I want to do 30 days of backup. I'm putting an agent on that machine. I'm backing up from that client directly to S3 using deduplication, and I'm only storing metadata in both a dedupe engine and a catalog.
Can I back up to on-premises?
You could.
Can I restore to on-premises?
You could do cross-cloud.
AWS to Azure?
Yeah, but you're probably not going to want to do the regress costs.
Okay.
Even though it's deduplicated, it's 3 times more expensive to get it out than it is to store it in. Okay?
Okay.
So the moral of this story is we really feel that because of our architecture, we drive what we call the lowest cost to protect on-prem and in the cloud. And that's really something that we pride ourselves on, is making sure that the architecture drives an outcome at scale that's cost effective for our customers.
So Mark, can I ask you a question? If you're talking about dealing with the cloud, and you've got lots of people who want to build an environment in something like AWS where they've got it all written in code, so they can just build the environment from a set of effectively, not scripts, but you know what I'm referring to.
Yeah, like cloud formations,
yeah,
little button click and launch. Yep.
Can you do that with the backup piece as well?
Can you install the agent when you do that?
No. I mean, the actual software, so that
Can we use
for
that as
instance,
the source to orchestrate the deployment?
Absolutely. So I can build it, say, an entire environment that consists of maybe a few hundred servers, the backup environment, and the target might already exist, but I want to build a backup environment to be unique for that, run it for a couple of weeks, make sure it's all backed up, throw it away, but still keep the data. And I want to do that programmatically. I don't have to manage.
So I think there's 2 questions there. So the first one is, can someone use our APIs to configure auto deploy our kit inside of Amazon? And the answer is yes. Have we gone and made that simple and easy for you via Marketplace to make it simple and easy to deploy? Not just yet, but we are rapidly working there, and we'll get to that point in the very near future where we can actually, from Marketplace, have a small, medium build, single button click. We're trying to do that for both Amazon and Azure in rapid succession, which we have Marketplace agreements for both.
Right.
Okay.
So imminent.
Imminent for us to be able to empower you to do it on your own.
Yeah.
Just out of Marketplace, very imminent there. For you to go take a more complicated setup that you want to customize, you can do that today. Okay. Now, I talked about this to your point earlier about kind of the different models that we deploy. We have a protection storage, build your own. We have a pure software version of our stack, and then we have an all-in-one appliance. That's really the value prop of choice. And my point of view, based on all the customer interaction I've had, is that the bigger you are, kind of more likely you're going to have all 3.
So, I mean, you're talking about the protection software stack.
Yep.
Okay.
And that includes data domain for us.
Well, I know that, but the data protection, but you've talked up till now pretty much almost exclusively about the data domain technology and nothing else above that. And when I'm talking to customers and working on big RFPs for data protection, like we're talking 20, 30, 40 petabyte environments that are all over the place, the targets are actually the last thing we discuss. We discuss what's going on the front end, from the data management, what we can do, not just about backup, because backup is one component of data management.
Yep.
Data protection is one thing. So we've talked about data protection a lot, but we haven't talked a lot about any things around data protection about, you know, and I work with a bunch of different vendors, right? About any, you guys looking at extracting any of the value out of the data that you're bringing in with these, through these tools? Because you're talking about Network and Avamar, and I know there's been a lot of work in Networker recently to redo a lot of stuff. Love to hear about that. Hopefully we do.
Yep, you're gonna see. I mean, so today we're gonna show you kind of, listen, you're kind of skipping ahead, and that's good because we're on kind of the same mindset here. The purpose of the architecture wasn't to drill into a particular software package, because for us, they're both kind of empowered to do the same things from this architecture standpoint. They both do client direct with Boost. They both have efficient proxy management automation. From a VMware standpoint, both of our software stacks, Avamar Networker have, VCD integration, have VRA integration, predefined plugins and workflows. They have, VROPS integration, right? So they're all kind of like on par when it comes to a VMware standpoint. Where we think it's interesting is just the overall architecture and the performance that we can get, right? And not necessarily the point of the architecture conversation wasn't to drill into a particular software. Now, we will talk about kind of our next gen software and what that's doing, and get into some of those conversations for you. And one of the key areas that I think that you would admit that you would say we have a room for improvement, let's just say, is one is we have a lot of products, right? That's definitely one of the things that you would say. And because of that, manageability and management of our solutions is one of the other pain points that people point out, right? I would argue that we have the best data movers. We have a very efficient architecture at scale and performance in an enterprise. Really, it's tough to match what we're seeing. And because of that, right, we use the least amount of kit to produce an end result at scale, and that drives a lower TCO over time. And due to our architecture in the cloud, we're extremely cost effective compared to other people, not only being performant, but cost effective. But that being said, we need to be easier to manage, easier to deploy. We need to have some more targeted commercial offers to take advantage of the Dell EMC machine that has such a massive sales force in that commercial space, where the classic Dell EMC kind of data protection target was like that, 40 terabyte and up, 20 terabyte and up kind of market, and we didn't necessarily have the right package price promotion type solution for the low end. That's for the future. But I want to transition now over to Mr. Rich Foman to come in and talk.
Just make a
Yeah, go
comment.
ahead.
I think our audience is not really interested in the sales force of Dell EMC, but we're really looking at the solution and what it uniquely does to help the customers. Because frankly, enterprise customers don't really care about sales forces.
Fair enough. The point is the commercial customer has specific needs around ease of use and ease of deployment, and that's where we're trying to get, to make it easier to deploy, simpler to start out, lower ASP, and more scalable on the way up, right?
Yeah.
That's really the point of my argument.
Okay. I suspect we'll be covering this later, but one thing I did notice clearly is Recover Point is not on that list of tools integrated into the DD Boost section.
Well, that's not actually necessarily true. And
Okay.
so after Rich, you'll hear about how we're using that Recover Point technology integrated with Data Domain to drive that hypervisor direct stuff.
Okay, that was the question I'm looking at, because I'm going, hold on a minute, we've got this Recover Point tool,
Yep.
and I'm only seeing Avamar and Networker here, so
So
good to hear.
you've hit it right on the nose. We're taking the power of the tools that we have and really starting to try and do some more unique things with it. So on the front of ease of management and taking our products and really kind of starting to pivot to more of a modules story, I want to turn it over to Mr. Rich Foman. He's going to give you a preview of what our technology looks like today in this front, something we call Data Protection Central. I'm really trying to make it easier and simpler to manage the different use cases that our customers need to deploy.